Hello guys, my name is John Michael E. Reyes and this is the chapter 5 Ethernet Fundamentals. Then let's continue. Objectives, Ethernet Fundamentals, Ethernet Operations. Then Introduction to Ethernet. The success of Ethernet is due to simplicity and ease of maintenance as well as its ability to incorporate new technologies, reliability, and low cost of installation and upgrade. Then, comparing LAN standards, OSI layers, and LAN specification. As you can see here, data link, this is the physical layer, then the data link is considered, the MAC sublayer is the one who communicate with the physical layer. Then the LCC sublayer is the one who go with the Ethernet. Then LAN specification, IEE. Then as you can see in here, there's the specs. Then OSI layer 1 and 2 together are the access protocol. Ethernet, fast Ethernet, gigabit, Ethernet, token ring, FDDI, frame relay, ATM, PPP, HDLC, and so on. These are the delivery system protocols independent of network OS, upper layer level protocols, TCP, IP, or IPX or SPX, sometimes called access method, access protocol, access technologies, media access, LAN protocols, WAN protocols. Then IEE is standards, divided OSI layer to 2 into sublayers, the MAC or the media access control, traditional L2 features, transition down to media, then the LLC or the new L2 features transition up to the network layer. Then LLC or the logical link control allows part of the data link layer to function independent of LAN access technologies, protocols, and methods. Provide service to network layer protocol while communicating with access technologies below it. LAN access technologies, Ethernet, token ring, FDDI. Then Logical Link LLC participates in the data encapsulation process. LLC PDU between layer 3 and MAC sublayer adds control information to the network layer data to help deliver the packet. It adds two fields, destination service access point or DSAP and source service access point or SSAP. Support both connectionless and connection-oriented upper layer protocols. Allow multiple higher layer protocols to share a single physical data link. Then, naming. Ethernet use MAC address that are 48 bits in length and expressed as 12 hexadecimal digit. The first 6 hexadecimal digits which are administered by IEEE identify the manufacturer or vendor and thus compromise the organizational unique identifier OUI. The remaining 6 hexadecimal digits represent the interface serial number or another value administered by the specific equipment manufactured. Then, layer 2 framing. Framing is the layer 2 encapsulation process. A framing is the layer 2 protocol data unit. A single generic frame has section called fields and each field is composed by bits. These are somewhat bits, the 0, 1, 0, 1 as you can see in here. Then they are composed with bits. Then framing. Why framing is necessary? Frame format, the diagram generic frame format. As you can see in here, these are the framing. Then why framing is necessary? Binary data is a stream of 1 and zeros. They are somewhat binary. Then framing breaks the stream into this parable grouping, start and stop indicator fields, naming or addressing fields, data fields, quality control fields. Framing is the layer 2 encapsulation process. A frame is the layer 2 protocol data unit. Then, generic frame format. The generic frame format is address fields, source and destination map, type of length field, data field, FCS, frame check sequence field, frame stop field. This is somewhat the start frame field is already at the start. Then these are the how they are being arranged. Then Ethernet frame fields, some of the field permitted or required in an 802.3 Ethernet frame are as follows. Preamble is a 8-bit. The start frame delimiter is a 7-bit. Preamble is a 7-bit field. Then the start frame delimiter is a 1-bit. Then destination address is a 6-bit, and source address is also a 6-bit. Then link is a type or length is a 4-bit or 8-bit. Then the data pad is up to 1500, and the frame check sequence is somewhat in a 8-bit or 6-bit. Then Ethernet operation, media access control MAC provides MAC addressing naming depending on access technology. Ethernet token ring FDDI provides the following data transmission control. Then collision resolution, it's somewhat the retransmission. Then layer 2 frame preparation, data framing, frame check sequence or FCS. Then media access control MAC protocols. The Ethernet IEE 8023, the logical bus topology, physical star or extended star, the non-deterministic first come first served. Then the token ring is somewhat the 802.5, the logical ring, physical star topology. Then deterministic token control traffic, older declining technology. Then FDDI, then IEEE 802.5, again the logical ring topology, physical dual ring topology, deterministic token controls traffic, near end of life technology. Then Ethernet CSMA or CD, host wants to transmit is somewhat the CMA is, these are the flowchart as you can see. Then it is a collision detection. Carrier sends multiple access with collision detection. Then Ethernet timing, any station on Ethernet network wanting to transmit a message first listen to ensure that no other station is currently transmitting. Then if the cable is quiet, the station begins transmitting immediately. Then interframe spacing and back off, as you can see in here. These are the speed, slot time, time interval, and other stuff. Then let's proceed. Error handling. Collision are the mechanism for resolving contention for network access. Collision result in the network bandwidth loss that is equal to the initial transmission and the collision jump signal. This affect all network nodes, possibly causing significant reduction in network throughput. Types of collision: local, remote, and late. Then Ethernet errors are the following are the source of Ethernet errors: collision or rant, the late collision, jabber, long frame, range, short frame, collision fragment or rant, FCS error, alignment error, range error, ghost or jabber, and many more, I think. Then FCS and beyond, a receive frame that has a bad frame check sequence, also referred as the checksum or CRC error, differ from the original transmission by at least 1 bit. Then Ethernet auto-negotiation, a process called auto-negotiation of speed at half or full duplex was developed. This process defines how to link patterns, may automatically negotiate a configuration offering the best common performance level. It has the additional advantage of only involving the lowest part of the physical layer. Then I think that's all. No, link establishment. There are two ways to achieve a full duplex link: through a completed cycle of auto negotiation or by the administrative forcing both links partner to full duplex. And that's all for chapter 5, the Ethernet. Thank you.